Okay, next I will discuss a theorem, and the statement of the theorem is this. Theorem tell you that prove that the angular momentum of the system about a fixed point is equal to the sum of the angular momentum of total mass concentrated at the center of mass about that point and the angular momentum of the system about its center of mass. Now this theorem tells us that show that the total angular momentum, we have the total angular momentum of the system about a fixed point. Okay, this is the total angular momentum of a system about a fixed point. Is equal to the sum of two angular momentum. One is the angular momentum of the total mass concentrated at the center of mass about that point. Okay, and then the angular momentum of the system about its center of mass. Like this black underlined portion tell us, it shows the total angular momentum, and this green will shows that this green and blue, they are two different angular momentum. So this total angular momentum is the sum of this angular momentum, the green, plus the blue. The green angular momentum is the angular momentum of the total mass concentrated at the center of mass about that point, and this one is the angular momentum of the system about its center of mass. So first I will derive the relations, and then I will tell you that which one quantity represent which momentum. So for that I consider my system of particles. Okay, I consider my system. Okay, so here is the proof. So I consider my system. Let's suppose this is my system, any arbitrary system. In this system I have n particles, but in this system is somewhere in a coordinate system. Okay, now if there are n particles in this system, then there will be a center of mass of the system also, which is inside this system. Now let's suppose this is the ith particle of this system with mass mi. Okay, I pick one of the particle in this from this system, because we have n particles in this system, but I pick one particle from this system, and I suppose that this is the ith particle and its mass is mi, such that its position from this origin is ri. Okay, now I suppose that the center of mass is also somewhere in this system. Let's suppose this is the center of mass. Now it is the center of mass, so its mass will be capital M, and its position from this fixed point O, or this origin, is R. Now this is the center of mass position, and this is the position of ith particle. So here I will suppose that let mi is the mass of ith particle, Ri, what is Ri? This Ri, which is the position vector, the position of, or the position vector of ith particle, okay? With reference to point O. This is the position vector of ith particle with reference to point O. And then we have M. This capital M is the mass of the center of mass, and this capital R is the position vector of center of mass. CM means center of mass with reference to point O. Now here I will draw another position vector, this one, and this is the position vector of ith particle with reference to origin, because it started from center of mass and in on ith particle, so it is the position vector of ith particle with reference to center of mass, and I call it Ri prime. Here Ri prime is the position vector of ith particle with reference to the center of mass. Of the system. Now if we look at this figure, then this is the resultant, this is vector R. If I add vector R with this Ri prime, I get the resultant Ri by head to tail rules, like add all this vector by head to tail rules, then we have R is equal to Ri is equal to this Ri is equal to this R plus this Ri prime, this R plus Ri prime. Or I can write just like this. So I can write it just like this. Ri is equal to R cross Ri prime. So taking derivative of both sides with respect to time, of both sides with respect to time, taking time derivative of both sides, then we have d over dt of this side, which is Ri, is equal to d over dt of this side, which is R plus Ri prime. So here I have dRi over dt, which is equal to, here I have dr over dt plus dri prime over. So this can be represented as, this is the rate of change of displacement, which is I represent it by ri dot, okay, which is equal to this dr over dt I will represent by this r dot, and here we have dri prime over dt, so I will represent it by ri prime dot. Now this is the velocity, okay, rate of change of displacement is basically velocity, so I represent it by vi, and this is velocity, this velocity I represent by capital V, and this is also velocity which I represent by smaller v. So these are our velocities. Now we have three equations now, so I will rewrite the three equations again. One equation is this one, the other equation is this one, and the third equation is this one. So we have these three equations. Now here, what is vi? Vi is basically is the velocity of ith particle. This is the velocity of ith particle with respect to with reference to point O. Because here I mentioned that Ri, this Ri is the position vector of ith particle with reference to O, then Vi, the derivative of this Ri with respect to time, will give us velocity. Dri over dt will give us velocity of ith particle. So Vi is the velocity of ith particle with reference to point O. Similarly, we have V, this capital V. Okay, this is the velocity of the center of mass. Vi is the velocity of the center of mass with reference to origin. And what is Vi prime? These are velocities, so we have to put vectors here. Now, as I already mentioned here, that Ri prime is the position vector of ith particle with reference to center of mass. Okay, Ri prime is the position vector of this ith particle with reference to center of mass. Then if I take its derivative dri prime over dt, I get Vi prime, which is the velocity of ith particle. This is the velocity of this ith particle with reference to the center of mass. So here I will write Vi prime is the velocity of the ith particle with reference to center of mass. Okay, so these are the three velocities. So we have to keep in mind these three equations. So I will write these three equations again, which is Ri is equal to R plus Ri prime, and then we have Ri dot is equal to R dot plus Ri prime dot, and then we have Vi is equal to V plus Vi prime. These are very important equations. We will use them again and again in our further calculations. So I will stop my video here. In the next video I will proceed from this equation.